11.8 expectation. We're going to look at three problems here. Uh, First of all, we have an insurance company, and the insurance company has a 10% chance of paying out a $500 claim, 40% 1,000, 40% 2,000, 10% of paying out a $3,000 claim. The expected value of this is what we could expect the insurance company to, on average, pay out. In a sense, it's a weighted average. Well, we have these two columns. First of all, we're going to multiply these columns. It's probability times dollars. 0.1 times 500 is 50. You can do that on a calculator. 0.4 times 1,000 is $400. And 0.4 times 2,000 is 800. And 0.1 times 3,000 is 300. Okay, so 80% of the time they're going to pay 1,000 or 2,000, 10% 3,000, 10% 500. If we just add this column up, 300, 800, 1,100, and 400 is 1,500. 1,550 is the expected value. That's what would happen over the long term. So for instance, if we had 10 claims, you would expect $1,550 per claim in the long run. And you see that's kind of halfway in between here. It kind of makes sense. Now we have a second situation. We have a six-sided die is rolled. $10 is paid out if a 3 is rolled, and the game costs $2 to play. If we roll a 1, 2, 4, 5, or 6, the house keeps the money. Find the expected value. And we're going to consider the cost here. Now, the first thing we have to do is list the outcomes. There's an extra column here that wasn't in this first problem, but you'll see the math is the same. There's two outcomes, a 2 and everything else. I could list, or a 3 is rolled. Sorry about that, I made a mistake. We'll make that a 3 and everything else. I could list 1, 2, 4, 5, 6, but everything else suffices. Probability of rolling a 3 with a 6-sided dice is 1/6. And probability of everything else is 5/6. Now the dollars, you have to consider, if we roll a 3, what happens? We get paid out 10, but it costs $2 to play. So I'm going to factor that in. 10 minus 2, we really walk away $8 richer. Okay, and in this case, 5/6, we actually lose $2. We pay the house $2 and walk away. Now, the next column we multiply, probability times dollars. Over here it was dollars times probability. Which order you situate these columns is up to you. You can put dollars here, probability here, it will give you the same answer. This is 8/6 or 4/3. We end up getting, you can multiply 8 times 1 divided by 6, which ends up being 4/3, $1.33. And if you multiply -2 times 5/6, it gives you 10/3, -5/3, and it gives you $1.67. Okay. Now, if you add this up, add up the positive and the negative, well, guess what? We end up with negative. Guess we need a dollar sign here. Negative 34 cents. What does that mean? From a player's perspective, you can expect to lose 34 cents per game on the average. If you play 100 games, you're probably going to walk away $34 in the hole, roughly, give or take a few dollars. Of course, the house has to make money, and so this is 34 cents per game in the house's favor. Here's a third example. A contract costs $1,000 to bid. maybe we pay office personnel to write up the proposal, make all the copies, put in an envelope, seal it. There may even be an application fee for whatever this contract is. And the probability of winning the bid is 0.25. That can be based on experience. 25% of the time we win these contracts. If it's a public contract, low bid gets the job, and sometimes we win, sometimes we don't. And the contract will produce $10,000 in profit, okay, overall. And I probably didn't mention explicitly, that's not considering this. We do all our business, we take in revenue, pay our expenses, and we're $10,000 ahead, but you still have to take out that $1,000. So outcome, there's basically two outcomes, win and loss, okay? Probability of winning, 0.25. Probability of losing is not winning, 1 minus 0.25, or 0.75. Now the dollars, in the case of a win, 0.25, we show a profit of 10,000, but you have to take out 1,000, so it's only 9,000. Now the loss, in the event that we lose, guess what? We're out $1,000. Now we multiply these, 0.25 times this ends up being $2,250. And 0.75 times negative 1,000 is negative 750. And if we add this up, 2250 minus 750 is 1,500. So whatever business this is, this contract can be kind of a repeat type thing. We can expect on the average to earn $1,500 per occurrence on this one type of contract. Of course, 75% of the time you lose $1,000, 25% of the time you win big, you win 10,000 minus the cost of 1,000. On the average, $1,500 per contract. So that's expectation. Do your best on the homework. I think most of the problems fit this case. There's a roulette example. Just follow this format: outcome, probability, dollars, multiply straight across, add, and that gives you the expected value. So